Welcome to the Java programming course from Eduonix. In today's lecture, we will learn object-oriented programming with Java. Let's start with our core Java syllabus. And recall, we have completed Topic 2, Java Language Basics. Now we are moving on to Topic 3, Object-Oriented Programming with Java. In particular, Subtopic A, creating Java types with classes, interfaces, constructors, the this and super keywords. In Java, we use classes to create objects. Classes are templates or blueprints for objects. Let's start by defining classes. Java and other object-oriented languages allow you to create user-defined classes. This extends the type system with new object types. Defining new classes is a matter of defining the data each instance maintains and the set of methods that manipulate the data. Let's expand that a bit more. Basically, in a class, the instance variables store the data for the class, while the methods of the class define behavior. Think instance variables data, think methods behavior. Classes are defined with the Java keyword class. The source for a class must be in a file with a .java extension that has the same name as the class. The name of the class must be the same as the name of the .java file. It's case sensitive. Also, if the class is given the scope public, there can only be one public class in one .java file. Instance variables are initialized with default values as well as in the constructor. Constructors have the same name as the class but have no return type. There is an implicit instance of any object created by a class, and this implicit instance is accessed with the keyword this. We can have public, private, protected, and package scope. Generally, it's a good programming design to keep instance variables private and then access them with methods. The idea of private variables accessed by public methods is a Java bean. Let's go over the concepts outlined in defining classes in a concrete example. Here we have a class defined by the keyword class example, and it's contained in the file classexample.java. It has public scope. This means it can be accessed anywhere in the application. Also, as it has public scope, there can only be one class with this public scope in the file example.java. This class extends object. This highlights the extends keyword. This is inheritance and is explained further in the topic polymorphism. This class has an outer or top level scope defined by its opening and closing braces. Variables defined in this top level scope, if they use the static keyword, are class variables. If not, they are instance variables. Instance and class variables can be given default initial values by the compiler. This is a constructor. The constructor has no return type. See, the methods have return types or void for a null return type. The constructor is used when we create an object of the type defined by the class. In this example, when this object is created, this constructor allows an integer value to be passed in. This integer value here is private. It can only be accessed directly in this class. No external class or object can access this private variable. It is totally encapsulated. It's final. This means once it's assigned a value, that is its value for its life. Final values must be initialized in the constructor. Final instance values must be initialized in the constructor. Let's take this initialization statement out, and you can see the compiler immediately flags an error. This is the super keyword. The super method must be called as the first method in the constructor. The super method calls the constructor of the superclass, or the class that this class extends from. In this case object, this super will call the constructor of object. These are accessor methods. We have private variables, private instance variables that can be set and read by public accessor methods. This is the pattern of a Java bean. For a final variable, because it cannot be set to a new value, it is final, we only have the read method or get method. Now we will look at interfaces. What are interfaces? Essentially, interfaces are abstract classes with no instance variables or concrete methods. By abstract, we mean we cannot make an instant or an object from an interface. However, variables can be defined in interfaces. Java doesn't permit multiple inheritance from classes, but permits multiple interfaces. Interfaces in general, a collection of methods with specific signatures and behavior, specifies what a data type looks like to callers, in a sense a contract between the implementer and the caller. When a class implements an interface, it's like a contract to supply the methods for any interface it implements. They're good because they completely separate the specification behavior from the implementation. Implementation can be in different languages or on a different machine. We think of remote methods defined by interfaces. Easy to substitute different implementations for any one interface type. Easy to use multiple implementations for any interface type. And useful for implementing callbacks. Let's look at a concrete example of an interface. Here we have an interface named ConstantStore, defined by the keyword interface with public scope, defined in a file called constantstore.java. The same rules for the public scope, and only one interface with public scope in the file constantstore.java is allowed. Now, we've called this interface ConstantStore because it's become a good practice to store constants in interface classes rather than Java classes named constant. This is because interface has an optimized memory structure for constants. Here's an example of an interface method. This is an example of an abstract method in the sense as it has no implementation. There are no braces here, opening and closing, to define a scope block. In an interface, we merely supply the method definition. All methods in interfaces are implicitly public. It is not possible to have a private method in an interface. There's no need to declare the public keyword because it is implicitly there. Now, let's see how we use this interface. In our example class, let's change this clause to implements constant store. Now straight away the compiler flags an error, and the error is the class must be declared abstract or implement the abstract method show data values with a boolean in the signature in constant store. That's this method here we've defined. Now class example implementing this interface signs a contract with the interface to implement its methods. This has not been done, so let's implement the method now. So we implement the method show data values, and the compiler error has vanished because now we are fulfilling our obligations to constant store to provide an implementation of its methods. Notice the override annotation is at means an annotation. What we're saying here is we're overriding any implementation of this method in any superclass. Now notice the close relationship between inheritance, where we had extend objects, and now implementation, where we have implements constant store. This was one of the reasons for interfaces in Java, was to allow a multiple inheritance pattern, only we use interfaces, not classes. Now these constants are available in the class. These constants don't need to be defined. So let's show that now. Let's do a system out statement, and let's print the value of the data string. See, there's no error there. This class has access to the constants defined in the interface. This is an important and very useful fact of interfaces that should be exploited more, should be used more in Java programming. Let's look at our concrete example in action. So we've created a main method in our class example, that implements constant store, and we've created some example objects. Now look, we can pass in the constant 7. This goes into the constructor and is mapped to the integer variable. Now this is of type object, and this is of type constant 7. The compiler can map the constant 7 to the object integer. We can also pass in the object. Both are equally valid. Recall the super method must be the first statement in the constructor. See how we're using the constructor to create the object. The constructor is not like a method because it does not have a return type. Its return type, if you like, is an instance of an object of type class example. Now notice data is not defined anywhere in this class, but is defined in the constant store interface. See how the object has direct access to the constants defined in the interface which this class implements. Let's see it in action. Let's run the class. And we can see it's printing out the correct value for the constant data defined in the interface. This is good Java design, to use the interface to store constants rather than a standalone constants class. Let's sum up, firstly, by looking at the differences and the uses of interfaces versus classes. Often there is a choice between specifying some functionality as a class or specifying that functionality as an interface. There are no hard and fast rules for this. That is, there are no rules that say when something should be a class or something should be an interface. Here is some advice. Java supports only single inheritance. A class can only extend one class at a time. This is enforced so that class hierarchies are strict, so you can know what's going on in the code, essentially. Interfaces are useful for a general functionality across a variety of class types, and this would be impossible to represent in a single class hierarchy. So interfaces are useful for this, as they mimic multiple inheritance. Interfaces are useful for specifying the behavior at a high-level design level, as it provides maximum separation of specification and implementation. That is, we can map out some behavior without being too concerned for any implementation of that behavior when we're working in a high level designing code. Class inheritance should follow a is-a relationship. If a class dog extends animal, then a dog is an animal. Interfaces follow a behavior-like relationship. Recall, interfaces define a set of methods the class must implement. Recall, methods define behavior. Let's look at our interface again. Interface keyword. Methods are public by default and merely the definition of the method. When a class implements an interface, it signs up to a contract to provide an implementation for all the methods in that interface, and in fact, unless the class implements all the methods in the interface, it will not compile. Interfaces are a very good place to store your constants, a set of constants that can be called in many classes. When a class implements the interface, it has full access to all the constants stored in that interface.